Simple mail transfer protocol is a communication protocol for passing email between email servers. Remember that there's multiple protocols that you may come across when dealing with email. POP3 and IMAP are some of the classics, and they've been updated to support security. So you'll find an SMTPS, IMAP-S, POP3S, as well as doing things like MAPI over HTTP. SMTP is really just focused on the delivery of email, and it's typically going to occur leveraging TCP over port 25. A request and response dialog is going to be used between the client and the server, and the SMTP session consists of some commands originated by an SMTP client. And then there's going to be 3-digit codes that define the server responses that are actually going to be sent to the client. We'll take a look at what some of those codes are and what some of the commands are as we go through this. So starting off just looking at an email message, emails, just like a regular piece of mail that you'll get in the mailbox, are going to contain an envelope. And in that envelope, very similar to IP headers and TCP headers and Ethernet headers, we've got source and destination. Our source is defined as mail from. This is the sender of the message. And then the receipt, too, is going to be defining the recipient. Now, in order for that message to be sent, we typically think about these envelopes being layer 2, layer 3, layer 4. What we're looking at here is going to be basically at the application layer when we look at the encoding that's basically being performed here. When we look at DNS traffic, remember that DNS is what's going to make this routable. It's not a traditional routing table. I guess it is after we do our DNS steps. So are we going to use a routing table to deliver that email? Absolutely. But in order to do that, we've got to figure out what IP address we're going to be routing to. And in order to get that, we need to do some DNS. You may recall that the first thing that we look for is the MX record. Commonly just points to an A record. An A record is going to point to an IP address. These are message types. If you're not real familiar with this or this is new to you, if you just check out Wikipedia's page on DNS message types, or you can even do like a Google Images search and come up with a table, you'll see some of the common ones there. But these are the two that we're typically focused on for mail delivery. When we talk about MTA, this is going to be a mail transfer agent. It's software that basically transfers email messages from one mail server to the other. So if you think about internet traffic, we pass a packet from hop to hop, and those routers make the connections. We're not necessarily looking at router hops in this case. We're looking at email servers. But there's a good chance that you could have everybody maybe send their email into your local mail server. Let's say that I'm using Curio, and I've got a bunch of different domains, and I've got some complex marketing that I do. So maybe I take Curio, and I pump it to different postfix servers, and then you could basically NAT your different postfix servers depending on what you're doing in terms of maybe we're doing rewrites on portions of headers or just manipulating email in different ways. In order to do that processing, which is pretty common, what we do is we take our mail server and we say, hey, when you want to send email, here's the SMTP server. And your server's like, wait a minute, I thought it was an SMTP server. I go, you are, but when you need to send email forward, if it's not for a domain that you've got locally, pass it to this next hop. And it could be anything, right? Instead of using postfix, maybe you do in some of your open source solutions, we're going to be leveraging the ESA. And this can work, of course, both inbound and outbound. So this mail is going to be leaving the organization. We can leverage ESA, make sure we're not spreading malware, make sure we're not leaking any sensitive data. And of course, as traffic comes in, we can leverage many rounds of analysis and make sure that it's only clean stuff that we're accepting. So once again, just a deeper look at what happens in that SMTP communication. First things first, we've got to resolve where this email is headed to. So the user sends the email in, we look at the source, the destination, and we go, uh-oh, it's not local, let me route it. Well, in order to route it, I've got to find the destination for where it's headed to. So we look at that destination email address. And the domain, in this case, maybe it's a user that's at cisco.com, we'd find that MX record for cisco.com, which is mx.cisco.com. Logical enough. mx.cisco.com is going to have an A record. It points to an IP. So this is where I'm going to build that TCP port 25 connection. Now, when I get there, who knows what's going to happen, right? If we're accepting email, typically we don't require authentication. But if you want to relay email, if you want to send email to some other domain, I might make you auth first. That way I don't become a spam relay. So you do your TCP three-way handshake, we define who we want to send this message to, and the server may accept it or potentially reject it. See, this is that connection blown up in a bit more detail. Start off with our three-way handshake. Why? Get reliable sequence numbers on each side. Once we've got those reliable sequence numbers and we're in sync, let's start communicating. So we can see here, one side says mxsystem.com, SMTP. This is just an enhanced version of SMTP. It supports a couple more commands. Here we see hello, mail securex.public, mx.cisco.com, and here we see the mail is from this user, and it says okay. Receipt to this user, okay. There's a good chance that when you try to send a recipient to admin@cisco.com, it may come back with an error code, and it says that user doesn't live here. You could do it silently, where you don't tell the person downstream, or you could do it interactively, where you basically say, no, that's nonsense, that person doesn't live here. If you're verbose in your errors, you got to be careful because attackers can use that against you. They'll do attacks where they'll perform basically the mining of user accounts. They'll use a word list, and they'll just try different words at your domain, and they'll analyze what these codes are that come back. So, I say, hey, does Bob live here? They go, no, Bob doesn't live here. Go, does Ryan live here? And they didn't answer me. Because there's a verify command that you can use as well as receipt to. There's a couple different ways to do it. But basically, if I probe the server and I can distinguish whether between someone lives there or doesn't live there in these error codes, I could potentially identify user accounts. Just pretty neat, right? What would people ever use these codes for from a reconnaissance perspective? From our perspective, just looking at what does an ESA do with this, kind of similar to what a router does. It does access control lists that look at things like source and destination. Well, we're going to have rule sets that say, hey, just in the intake process, when email shows up, is this somebody that we're going to even deliver for? Because if not, you really don't need to send us any more data. We might just kill the connection right away. So as connections are established to the ESA, it goes through a lot of intelligent filters based on just the initial three-way handshake. And even more so, looking at who these domains are, and then corresponding, like, why is mail from this particular domain coming from this IP address? If that seems super weird or bizarre, we can take action. So a lot of intelligence actually comes out of this simple envelope and the way that the mail server handles those queries. Assuming that these are valid users, we continue and we bring in the headers. Again, we see from, to, subject, date, etc. And then the body is the actual email itself. This is the content. When it's done, again, you see some of the error codes. And that's just a little bit of a closer look at what's happening under the hood with your email. So high availability, this is critical, right? We go, what happens if email's down? Well, sales is going to be upset. Management is going to freak out. I don't think anybody's going to be happy with us. So when we think about high availability, this is a little bit different than what we saw in the firewalls. Typically, when we look at things like switches, routers, and firewalls, we'll take a pair of devices, we'll tell them about each other, and we'll go, look, you two are a team, work it out. You're the leader, you're the backup, and we typically define that with things like priority numbers, right? The only thing that's different, we're still using priority numbers, but the thing that's different is that the devices, the components, aren't constantly chattering back and forth to each other. If we look at things like switch stacking, if we take a look at things even like first hop redundancy protocols, HSRP, GLBP, VRRP, all of those redundancy protocols and systems have got constant hellos going back and forth for detection. Email's a bit different. When we set up our email servers, I'm not saying that you couldn't do some type of health check or add something on to monitor what's going on with those, but it's not necessary. The reason that I say it isn't necessary is it's because it's handled within SMTP itself. When you respond to that DNS request for the MX records, you can return multiple MX records. And you go, they're like, hey, where's your mail server? I'm like, which mail server? 1, 2, or 3? And you're like, oh, okay. And what you see there's priorities. And based on the priority, I would prefer to use one. If it's not available, then the other. So resiliency, redundancy is available. It's just a touch different than what we're typically used to using as network administrators, where we take those devices and we pair them together and they've got portions of each other's configs. This is really just handled through MX records. And here's a close-up look at that. You see that when we want to deliver mail to example.com, example.com's name server says, well, we've got two MX records, mail A and mail B. Mail A's got a priority of 10, mail B's got a priority of 20. So we do have redundancy, it's just the ESAs aren't configured to have to know about it necessarily.